So what we want to do here are talk about the different ways that we can collect samples. So what we're going to do is kind of describe the method, and then we're going to apply it to an example. For us, we're going to look at if we wanted to survey PCC students on how much they pay for housing per month. How could we go about collecting that information to maybe eventually find some average household payment per month? Talk about is a census. And a census is where we survey absolutely everyone, and we get all of the results back. So with the census, we sample the entire population. And with that, we end up with population data, which is very accurate, as we talked about before, but this is also a very difficult thing to do, because if I, for example, told you, okay, your project this term is to go out, collect a census, to talk to every PCC student about how much they pay per month, that would be very difficult to do, because you would have to survey every PCC student. And you'd have to get all of the results back as well. And that's just very difficult to obtain. So what we can think about here are some cons of this. The pros would be that this data would be very accurate, but some cons would be that it's difficult to obtain. And with that too, say the school hired us to take care of this, what they would probably do is pay us some money, and with that, this takes a lot of time. It takes a long time to collect all of this data. So if it takes a lot of time, that also means that it takes a lot of money, whether paying the people to conduct the survey or just resources alone can get very costly. So that's one method of taking a survey, is to collect a census. Another method would be to take a simple random sample, and that's where the sampled individuals are randomly chosen. And with this, if they're randomly chosen, that means they're all equally likely to be chosen. So with this, we sample size and then randomly select from the population. So what we could do is, say, use a computer to randomly select, and then we just choose a sample size. Let's say we select 100 PCC students to survey. And something that comes up is when we want to be random, we should really use technology to be random for us, because as people, if I saw that list and just started selecting randomly, there are all these little wires in our head that actually make us not that random as human beings. There would be some kind of bias coming through. But computers can be completely random, kind of giving this equal probability of selecting. This is really the best way to collect a sample. This is going to give you a very diverse group. With it being random, there's no bias coming through. And something you'll see for simple random sample, for short, you'll see that as SRS sometimes. And really the only kind of cons to this, because the pros are it would give us very good data, it'd be very diverse. Downfall, really the only one would be sample size. We need to make sure we have a large enough sample size. And for us, 100 is great. You just want to get careful, if the researchers say, okay, let's just sample 25 students. That starts getting to the verge of too small. So let's talk about stratified and cluster sampling kind of together, because their definitions are very similar in that both require separating into groups first. So we're going to population into subgroups for both of these. So that's our first step, into subgroups. And choosing the subgroups, it'll be some characteristic that'll kind of unify them. So we'll talk about some examples with that. So what I'd like us to do is kind of visualize this. If we have our population for both of these scenarios, we have our population, and we break both of our populations into these subgroups based on some characteristic. With stratified, what we then do is take a small random sample from and then take a random sample of some sample size from every group. So the visual I like for this is where we have our groups. It's like we're just talking to a few people, but it's a few people in every single group. So this is a nice way to make sure that if there's some grouping within our population, this guarantees that we talk to every single group. With cluster, this is where we break into subgroups, and then we just randomly choose some entire groups. So, and then we randomly choose entire groups. So what might happen here is, say we were using a computer to be random for us. If we have these subgroupings, maybe it says, okay, you want to choose 4 of them, talk to this group, talk to this group, and this group. And then what we would do is survey absolutely everyone in this group, and this, and here as well. But what ends up happening? Entire groups. So we'll kind of talk about, that's going to be probably our con for this one, that you do leave out entire groups, but depending on how you make the groups, it might not matter. So for example, with stratified, if we were trying to talk to these PCC students, what we could do is break them in, and if we're thinking about how paying for housing per month, in terms of breaking into groups, we could think about what would be beneficial, like what bias could start coming through with housing. And what I immediately thought of with this is I want to make sure we talk to all kind of economic standings. We want people in richer neighborhoods and in poorer neighborhoods and everything in between. So with that, what we could do is break Portland apart by neighborhood. So let's say we separate the students by neighborhood that they live in. And then what we could do is take some random sample from every single neighborhood. And this will just help guarantee that there isn't too much bias in the housing. So let's say then survey 30 random students from each neighborhood. So this is a great way to use groups to kind of guarantee that you interview across the board. The only sort of cons to this that you need to worry about, well, their sample size comes through, so make sure you have a large enough sample size. But also just, do the groups make sense? Are they separated in a way that's beneficial for our data? So like by neighborhood is good. If we separated, say, by the first letter of your last name, that wouldn't matter so much. Last name's not going to influence how much you're paying per month for housing, so separating by first so much sense for gathering this data. However, we would want to use that idea here, because when we break into groups for cluster, we kind of don't want the groups to make sense. We don't want it to the housing per month, so I wouldn't want to use neighborhoods here because I don't want to leave out entire neighborhoods, because then maybe we only randomly select poorer neighborhoods or richer neighborhoods, so that would influence our data. However, if we separated by first letter of last name here, that would be okay, because this would be like if we only talk to people with the first letter of last name A and D and M and P, like leaving out B and other letters won't necessarily matter that much. So here we can separate students by the first letter of their last name. And then what we want to do is randomly select some letters. Then select, and we could choose, let's say we select, I don't know, 10 letters, and survey everyone in those groups. So what this will do is then say the computer randomly selects the letter A. If this is A here, we would talk to everyone that's a PCC student that has a last name that starts with A, and they would be part of our survey group. So the only cons here, and it's a con if we don't think about these groupings, is the entire group. And when we choose these groups, we just want to ensure that it's okay groups are left out. So that's stratified and cluster, and I really like these visuals to help out remembering the difference between the two of those, because they easily get mixed up. Our next one is systematic sampling, and this is where we survey every nth individual. And it's just some number. You can survey every third individual, every 20th individual. Choose a number, and it gives this kind of interval for which to survey people. And it's up to the researcher to choose n. So like for us, we could make a list of PCC students, of all of the PCC students, and survey every, let's say, 15th student. So if we survey every 15th student, we'll get a decent sample size for taking every 15th out of all PCC students. And it should be pretty random by going just by interval, and especially if we didn't really organize how the PCC students did. So systematic's a great way to kind of get that randomness coming through. The only cons is that you need to make sure you have a large enough sample. When you choose this value for n, like for PCC, I wouldn't want to use every 1,000th student, because if I took every 1,000th student, in the end, I just won't have that many students in my actual sample. So you want to choose this strategically. Something else that comes through with this is that you need to count the people or things that you're surveying. So it needs to be a countable group, or something that you can list out and actually get every 15th person. And then our last one is multi-stage, and this is where you use multiple sampling methods, where you can combine two or more of the methods that are up above. And in terms of cons of this one, it just kind of inherits the cons of the methods that were used above. So whichever methods you choose, those kind of cons come along with it. So for example, say we started with cluster sampling. So if we were working with our PCC students, we could randomly select those 10 letters. And then say, once we select those 10 letters and have our list of students, maybe that's just too big. Maybe that's too big of a sample to survey and we want to make it simpler. Then what we could do is, using that list, then we could run a simple random sample. So with fixated on those 10 letters, then we could randomly select 100 students. So it's a way of combining methods. It doesn't have to be those two methods, but mixing any of the two above will make a multi-stage sampling method. All right, on the next video, we're going to talk about bias and how bias can sneak into these samples that we're taking.